The effect of outliers. An outlier is a piece of data that lies an abnormal distance from the rest of the data. Let's have a look at an example. In this data set, we have 5, 3, 6, 4, 27, 5, and 5. We can see that we have one piece of data that is significantly larger or an abnormal distance from the rest of the data, and that is 27. So let's have a look at the effect an outlier has on the mean, median, and mode. Using the same example that we had on the previous slide, let's calculate the mean, median, and mode of the following data. Our data is 5, 3, 6, 4, 27, 5, and 5. Pause the video now and practice calculating the mean, median, and mode of this data set. Okay, when we calculate the mean, we add up all our data values and divide by how many there are. So we have 7 data values. So our mean for this data set will be 7.9. Now let's calculate the median. Remember, you must put your data from smallest to largest first. Once you have done this, you will see that the median is 5. Now let's have a look at the mode. The mode is the most occurring piece of data, and in this data set, it is 5. Okay, now let's calculate the mean, median, and mode of the same data set, but without the outlier. So we'll cross out 27 and we won't use it. Pause the video now and practice calculating these statistics. Okay, so let's have a look at the mean. Once again, we have to add up all the data, but this time we're not including the 27, and we also only have 6 pieces of data. So our mean will be 4.7. Next, let's look at the median. Once again, make sure you put it from smallest to largest. We can see that there is actually 2 pieces of data in the middle, so we will take the average of them. 5 plus 5 divided by 2 equals 5. And the mode, once again, is the most occurring, which is 5. Let's compare both lots of statistics that we calculated. We calculated with the outlier and without the outlier. So when we look at with the outlier, we can see that our mean of 7.9 was significantly higher than our mean without the outlier of 4.7. This is because the mean is the one measure that is most affected by outliers. The median can also be affected, but the mean is affected the most. As a result of this, when we're looking at data that has the potential to have outliers, sometimes we don't use the mean to calculate the central tendency of that data because it can give us an unreliable result. So we might use either the median or the mode, because remember, the mean, the median, and the mode are all measures of central tendency. So sometimes we have to choose which one gives us the best measure of central tendency of a certain data set. And this can be different depending on the data set. So let's have a look at some of the things that can be affected by outliers. House prices are an important one. A lot of the time in the media, when you see people saying that the average house price is a certain amount, they will use the word median house prices. And the reason for this is that the mean is very affected by outliers when it comes to house prices. Think about where you live. There are probably some houses that are priced a lot lower, and then there's some houses that seem to be all around the same number in the middle, And then there might be multi-million dollar houses up the top end also in your area. So if you were to calculate the central tendency of house prices in your area and you included those multi-million dollar houses, then the mean house price would be affected by those and it would be a lot higher. That's why you would probably use median house prices in your area. Wages, temperatures, and rainfall are also affected by outliers. So in summary, outliers can affect the central tendency of data sets. It's important that we're aware of outliers, we can recognise them, and then we can make a decision on which measure of central tendency would be best to use.